Elementary O1, problem 5. So the question is to state whether it is less than, greater than, or equal, whether this fraction is less than, greater than, or equal. Okay, so these are the options you have. So a brief recap. Notice this, as you notice, it looks like an L, right? It looks like an L, so this is less than, okay? Whereas the opposite is greater than. All right. So now you have things like less than or equal, less than or equal, right? Likewise, you have greater than or equal, greater than or equal. All right. So the question is this fraction less than this, or greater than this, and so on. The way you go about it is you convert it to whole numbers. A question about whole numbers. The way you do it is cross multiply. Keep in mind the numerator, the number on the top. When you cross multiply, that stays on the same side. So 11 is the number on the top, 2 is the number on the top, right? 2 is on the right hand side. So when I cross multiply, that stays in the right hand side, and 11 times 7 will stay on the left hand side. So 11 times 7 continues to be on the left hand side because number on the top is 11 on the left hand side. You compare that with 2 times 5. So 2 is on the right hand side, so 2 times 5 continues to be on the right hand side. Now let's look at this. This is 77. How does it compare with 10? Well, 77 is greater than 10. 77 is greater than 10. So my original fractions inequality is carried in the same direction. So I have greater than. Sorry. Next. Similar questions, right? Actually, this is slightly different. When you have same denominator, it's easier. Then I simply look at the numerator. How is 16 compared to 8? 16 is greater than 8, so I don't need to do this cross multiplication stuff. When I have the same denominator, I simply look at the numerator. 16 is greater than 8. All right. Now here the denominators are different, so I will need to do something here. Okay. So we are looking at fraction 17 over 8. Compare it with fraction 17 over 16. You can do the previous approach, and here is yet another approach. Why do I show this another approach? Because it's somewhat straightforward. If you notice, I could get the same denominator rather easily in this particular case. That's why I'm trying this method, okay? If I couldn't have found a common denominator quickly enough, then I would approach the previous method. But notice here, 8 and 16, all I have to do is multiply 8 by 2 and I get a 16 in the denominator. But whatever I do downstairs, I must do upstairs. Yeah? So if I multiply by 2 to the denominator, I must multiply by 2 to the numerator. At this point, if you notice, what happens is 17 times 2 is 34, 8 times 2 is 16. How does that compare with the fraction 17 over 16? So notice we have same denominators, So all I need to do is compare the numerators. 34 is greater than 17. So 34 over 16 is greater than 17 over 16. So all of this is greater, this is greater. So this is greater. Okay. Next. Reduce the fraction. All right. So they are asking us to reduce the fraction. So let's try 9 over 15, right? So I will rewrite 9 as 3 times 3 over 15 is 5 times 3, right? Once I do that, you notice times 3 times 3. So 3 is a common factor. I can cancel it. I have 3 over 5. Next problem. 52 over 78. Okay. I can go over, I can keep reducing over several stages, right? You notice this is an even number, so 2 goes in both. Okay, so 2 times what is 52? Well, you can check a little bit. So 2 times 26 is 52, 2 times 39 is 72. So that means 2 is a common factor. I can get rid of the 2. All right. Does anything else go here? Look at that, 26, right? So this is equal to. Now this takes some practice. If you notice, 26 is nothing but 13 times 2. And 39 is nothing but 13 times 3. Okay? This takes some familiarity, and the more problems you do, better you get at it. So 13 reduces in both. And eventually your answer is 2 over 3, which cannot be reduced any further. Next problem. Express each as a fraction in its simplest forms. Well, you first have 0.75. Any decimal number, how do you reduce it to fraction? Look after the decimal point, how many digits do I have? 2 digits, right? 1 and 2. So I divide by 100. So notice 100 has 2 zeros. I need 100 because of the 2 digits. Now I can forget the decimal point and write the number as it is. 0.75. 0.75 is nothing but 75. Okay. Now they want you to write the fraction in its simplest forms. So you need to reduce. So notice that ends in a 5. This ends in a 0, which means 5 goes in both. 5 is a factor in both. All right. 100. How many? 5 goes in 100. How many times? 20. 5 goes in 75. How many times? 15. So fantastic. So 5 is a common factor. It cancels. All right. I can notice 5 goes in both again. 5 goes in 15 3 times. 5 goes in 20 4 times. So another 5 cancels. So I have 3/4. So I will write 3 over 4. Write it in that fashion. /4. Okay. Likewise, the next one, 0.4. So it is a fraction. So notice after the decimal, I have only one digit. So I have 10. 1 0 for each digit after the decimal point. Now ignore the decimal point. What do I have? 0, 4. That is simply a 4. Okay. Now at this point you can start factoring. 4 is 2 times 2, whereas 10 is 2 times 5. Okay. So at this point notice 2 reduces the 2 and I have 2 over 5. Okay. Next problem. Put your answers in an answer box. So you want to write this. Okay, so you have some numbers. You want to write them in mixed form. All right. So this requires a bit of drawing. So, all right. So let's start here. 7 over 4. The way you approach is you write, you have to do long division, right? Until you get good at it, do this by long division. How many 4s go in 7? 4 times 1 is a 4, and you are subtracting, you are left with 3. Okay, so 1 whole, so 7 over 4 is the quotient, that is 1 whole, the remainder, that is 3, over whatever you are dividing by, that's a 4. So remember, the denominator continues to be a denominator. So this is 1 space 3 over 4. That's how they want you to write. Number space your fractional part. So this is the whole part. This is the fractional part of your mixed number. All right. So likewise here, let's try 18 over 5. 18 is inside, 5 is outside. The divisor, that is the bottom number, is the divisor, the one who divides. 5 goes in 18 3 times. 5 times 3 is 15. When you subtract, I get a 3 and nothing more. So that's the whole part. This is the remainder over 5. 5 is the divisor. So the denominator continues to be the denominator in your fractional part. Whole part, fractional part. So 3 space 3 over 5. Last is 48 over 9. Nine goes in 48 5 times. 9 times 5 is 45. So when you subtract, 3 is left over. So that's the whole part. This is the remainder. Whatever remains gives you the fractional part. Okay. So notice that fractional part can be reduced. 3 goes in both. 3 goes in 3 once. 3 goes in 9 3 times. All right. 5 and 1/3. Okay. Next problem I'll start in my next video.